What we have here is dy dx equals 2x over y. This is called a differential equation because it's an equation that is the derivative of something. And this is a common kind of problem to see on the free response questions, where if you can just follow the process the same way every time, you should and always kind of need to get all 5 points for this kind of problem. So in the first few examples, we will come up with the initial equation, and then the last 4 examples we will actually solve the equation all the way. So the first step every time you're trying to solve a differential equation is you need to do what's called separate the variables. So in this case that means get all the x's on one side and get all the y's on the other. The first thing I'm going to do is multiply both sides by dx and both sides by y. So that's why the y dy equals 2x dx. And notice now I have all of the variables on each side. I have all my y's on the left and all my x's on the right. The second step at this point is, so you would get 1 point just for separating the variables. The second step is just to integrate both sides. Right? So on the left I'm going to integrate that with respect to y, and we'll get 1/2 y squared equals, on the right we'll get x squared, and hopefully you're thinking, well, there should be a c on both sides, and that's true. There should be a constant of integration on both sides. Now, we don't know what that constant is, and there's no reason for us to think that they're the same. So what I'm going to do is bring all my constants over to one side. And so typically imagine I've just added both the constants to the right, and so that's why my work will just be 1/2 y squared equals x squared plus some constant c. So we've gotten 1 point for separating the variables, we've gotten 1 point for integrating correctly, and you must have the plus c at this point. If you don't have the plus c at this point, if you forget the constant of integration, then you can't get any more than 2 points on a free response question of this type. But with the plus c, we can continue on. Now, our next step is, if we knew a point, we would solve this thing for the constant of integration, and then we would solve for y. We don't have a specific point, we're just trying to find the original function, so in this case we're going to solve for y. I'm going to multiply both sides by 2, so y squared equals 2x squared, still plus c. We don't know what the constant is, but multiplying a constant by 2 won't change it. And now I'll take the square root, so y equals the square root of 2x squared plus c. Right, notice that I've solved for y, and that was the task. Let's do another problem. This time we'll do a problem that involves us actually solving the whole thing. So here we have a differential equation, x e to the negative t power dx dt equals 1. And we're told that x of 0 equals 1. And that's our initial condition, that when the input is 0, the output should be 1 for our original function. Our first step is to separate the variables. So what I'm going to do is multiply both sides by dt and divide both sides by e to the negative t. So we'll have x dx equals, it'll be 1 over e to the negative t dt. Now, by property of exponents, I can bring that e to the negative t up, and we've got x dx equals e to the t dt. We've separated the variables. So that's 1 point on a free response question. Our next step is to integrate both sides. When we integrate both sides, we've got 1/2 x squared equals e to the t plus c. So I've got to remember to have the plus c right after I integrate. I've integrated correctly, I've got the plus c, so I've gotten 2 points, and I can continue on with my work to get the rest of the points. I'm of the opinion that right now is the time to solve for c. So what I know is that when x has the value of 0, t will have the, or no, when t, because that's my input, has the value of, when t has the value of 0, x has the value of 1. So by substitution, we've got this. And now we're able to solve this for c. E to the 0 power is 1. Subtracting 1 from both sides, we would find that c equals negative 1/2. So our third point is for substituting correctly our initial condition. Right, so we read that when t is 0, x is 1, so we made that substitution. Fourth point is for actually finding c correctly. So now we know what our initial equation was. It's 1/2 x squared equals e to the t minus 1/2. And now we're able to finish this problem. We just need to solve in this case for x. So multiplying both sides by 2, x squared equals 2 e to the t minus 1. And take the square root of both sides. X equals 2, the square root of 2 e to the t minus 1. This is our fifth point because we've actually gotten the correct equation, and we've shown all our work the entire way so that we'll get all 5 points on this free response question. We will do a few more examples. Let's start with number 10. Here dy dx equals 1 plus x over x times y, and we know that y sub 1 equals negative 4, which means that when the input x is 1, the output will be negative 4. Point number 1 is for separating the variables, so I'm going to multiply both sides by y and by dx. So we'll have y and dy equals 1 plus x over x dx. I'm going to clean up the right side just a bit before I integrate and rewrite this as 1 over x plus 1 dx. Point number 2 is for integrating correctly. So when I integrate this, I'll get 1/2 y squared equals the natural log of x, and it's the natural log of the absolute value of x, plus x plus c. Now I'm going to solve for c. I know when x has a value of 1, y has a value of negative 4. So 1/2 times negative 4 squared equals the natural log of 1 plus 1 plus c. This means that 8 equals 1 plus c, because the natural log of 1 is 0, which means that c should equal 7. So I know that my initial function is 1/2 y squared equals the natural log of the absolute value of x plus 7. Multiplying both sides by 2, y squared equals 2 times the natural log of x plus 2x plus 14. Square root of both sides, y equals the square root of 2 times the natural log of x plus 2x plus 14. Can't forget the absolute values on the natural log as well. Let's do 2 more examples. dy dx equals y squared plus 1. A common mistake would be to subtract y squared right now, and you can't do that. What I'm going to do is first multiply both sides by dx. So dy equals the quantity y squared plus 1 times dx, and then I'm going to divide both sides by y squared plus 1, right? So 1 over y squared plus 1 dy equals dx. The next step is to integrate. The integral of 1 over y squared plus 1, well, we know it's going to be the natural log of the absolute value of y squared plus 1. But it can't just be that. What else is going to be happening here? I hope you caught the mistake before I did. 1 over y squared plus 1 is not natural log. That's inverse tangent. So this is the inverse tangent of y equals x plus c. And we're told, now that we can solve for c, that when x is 1, y should be c. So the inverse tangent of 0 equals 1 plus c. Well, what angle has a tangent value of 0? Well, that's 0 equals 1 plus c, which means that c equals negative 1. So our initial equation should be the inverse tangent of y equals x minus 1. To get y by itself, we'll have to take the tangent of both sides. So y equals the tangent of x minus 1. Let's do one more. For our last example, we have x plus 2y times the square root of x squared plus 1 dy dx equals 0. Separating the variables is going to be tricky at first, but I'll subtract x from both sides. So 2y times the square root of x squared plus 1 dy dx equals negative x. Now, if I divide both sides by the square root of x squared plus 1 and multiply both sides by dx, we have negative x over the square root of x squared plus 1 dx. And that looks an awful lot like something related to arc sine. And this should be not dx, but 2y dy. If we integrate both sides, we'll get y squared equals I'm not seeing what's going to happen immediately with this integral of x, so I'm going to use u substitution. If u equals x squared plus 1, then du equals 2x dx, or I'm going to divide both sides by negative 2, and negative 1/2 du equals negative x dx. By u substitution then, what I'm really working with is negative 1/2 times the integral of 1 over u to the 1/2 du. And when we integrate that, we'll have negative 1/2, or when I change it, this is negative 1, the integral of negative 1/2 u to the negative 1/2 du. So this would be negative 1 u to the 1/2, which means since u was x squared plus 1, it's negative 1 times x squared plus 1 to the 1/2. So back to our actual problem, this becomes negative x squared plus 1 to the 1/2 plus c. Now I'm going to solve for c. I know that when x is 0, y is 1. So 1 equals negative 1 to the 1/2 power plus c. 1 equals negative 1 plus c. So c equals 2, which means that my original equation is y squared is equal to the opposite of x squared plus 1 to the 1/2 plus 2, and I need to take the square root of that. So y equals the square root of 2 minus x squared plus 1 to the 1/2. And that is solving differential equations by separation of variables.